Hello everybody, welcome back. Now I am here with Dr. Carl once again. We have been on an epic journey. We've traveled from South America all the way to Antarctica, across to South Georgia, and we are now in the Falklands, as you can see. Dr. Carl, how are you?
Peachy keen, Dr. Gavin. We're doing it again.
Now this week we're talking all about galaxies. We made our way out from the Earth, we went to the moon, we talked about the inner planets, the outer planets, the sun, stars. We're now into galaxies. It gets really, really big here. Dr. Carl, can you tell us, we're part of a galaxy. What galaxy are we part of?
It's called the Milky Way because it looks, if you're in the southern hemisphere, like a spray of milky dots across the sky.
Ah, that's right. And there is a cultural story attached to that. And actually, you'll have to look that up for yourself. Now, our galaxy, it seems very complicated. There's lots of things swirling around. What's actually in it?
Roughly 300 billion, is that the right number? Yeah, 300 billion stars in our galaxy. And on average, with our little survey, they've got about 1.6 planets each. So there's maybe 500 billion planets, maybe with life, maybe not. And then there's the stars that they go around. But that's only 4 or 5% of all of the mass in our galaxy. And that's the stuff we can see with our telescopes. Another 25% is dark matter. Nobody knows what it is. Maybe you'll get a Nobel Prize for discovering it. And another 70% is dark energy. Nobody knows what it is. Maybe you'll get a Nobel Prize for discovering it.
So most of our galaxy is things that we don't really understand.
Correct. That's what science is. Knowing what you know and knowing what you don't know.
Now, there's about 2 trillion galaxies, each with about 1 billion stars. That's a lot.
Close enough, yep.
That's right. And, you know, in these galaxies that we're talking about, there's distinct types. There is an elliptical galaxy and a spiral galaxy. Can you tell us the difference?
If you look at a galaxy from the side, it looks like 2 soup bowls stuck together with a bit of a bulge. But then if you look at them from above, either they're just like a smooth soup bowl or they've got little arms coming out. And these are the spiral arms.
Oh, wow. Now, how do we see these galaxies? How do we get I mean, they're very far away from Earth.
We started off with glass. It's amazing that with glass and 4 centuries of work with glass, you know, mirrors and lenses, we've discovered so much. So we just get bigger and bigger telescopes. They're up around 10 meters across. 10 meters is like bigger than a small van.
That's right.
And a mirror 10 meters across. So with big glass and many hours, here's a hint. Astronomers call their telescopes light buckets.
A light bucket?
Yeah, so you got a light bucket, you put it out, you take it outside at night, you leave it there, it just gathers in all of the photons.
Wow.
And then you look what your light bucket has gathered. That's a private joke that astronomers have.
It's like collecting stars from the universe.
Yeah, in your little bucket, which is 10 meters across.
Now, a lot of children around the world, including me when I was a child, I was quite afraid of black holes because they were these mystical kind of things in the universe that sucked things into them, and it was really quite scary. Can you tell us, how is a black hole actually formed?
It's formed usually when a star dies. So a star is kind of a living creature, kind of, and there's the nuclear fires pushing out and gravity sucking in. When the nuclear fires go out, it will suck in. If it's heavier enough, if it's maybe 10 times the mass of our sun, it will shrink all the way down past a white dwarf,
right,
the size of the Earth, past a neutron star, 20 kilometers, to a black hole. And the size of a black hole is not that much, it's zero.
It's zero?
This is really hard to get your head around. A black hole has zero size, but it might have 5 million times the mass of our sun.
My goodness.
Or it might have 5 billion or 50 billion.
Wow.
But the size of every black hole is the same, which is zero. They have no size.
That is so hard. Maybe we can do more research on this topic. But also the last question I have for you is this. In lots of children's storybooks, in fantasy books, we get sucked into black holes. Can we actually be sucked in?
Sure, in the same way that a meteor can get sucked into the gravitational field of the Earth, or an asteroid or a comet gets sucked into the sun. But they're not just automatic sucking machines that destroy everything. So if our sun were magically or scientifically to be turned into a black hole, all that would happen would be that there'd be no energy coming out of the sun or the black hole. We would still continue to orbit this thing at the distance that we're orbiting it at, and the size would be the same. The sky would be black, everything would get cool very fast, but we wouldn't get sucked in automatically. However, if you get close enough to the sun or a black hole, you will get sucked in.
Okay, it's just to do with the gravity.
And the distance, how close you are.
Exactly. Okay, now this week we want you to research galaxies near and beyond. There are so many to choose from. In fact, you've got trillions to pick. Now, once you find a galaxy you're interested in, let's do some research around what it's made of, where it's located, and maybe it even has a name. And if it doesn't have a name, just like your asteroid, Dr. Carl, you might be able to name it after yourself. Dr. Carl, it has been a pleasure.
Thank you, Dr. Gavin.
And we'll see you next week.